Here we have a problem in algebra 2, that is we have to solve for x in this equation. Okay, now let me start working on this. In my first step, what I'm going to do is I'm going to write this number 4 as 2 square, and since we have an exponent x for this 4, the same exponent is taken for this 2 square. Negative 3 times 2 to the power of x positive 2. I write this 2 to the power of x positive 2 as 2 to the power of x times 2 to the power of 2. So how can I write this one? This 2 to the power of x positive 2 as 2 to the power of x times 2 to the power of 2. Let me consider the product rule in exponents, that is a to the mth power times a to the nth power. Here I multiply two terms with the same base. Whenever I multiply two terms with the same base, I can take the base once and I have to add the exponents, that is m positive n. Okay, now let's do this in reverse order. That is, let me consider the stuff on the right side. We have two values are added at the exponent. Whenever two values are added at the exponent, we can take the base separately for each value and multiply them as we have over here. So that's what I've done over here. Because here at the exponent, we have x and 2 are added. So we can take this base 2 separately for x and 2 and we have to multiply the results we have over here. And also the evaluation of this 2 to the 5th power is 32 equals to 0. And also let me consider the another rule in exponent, that is a to the mth power whole to the nth power. Okay, here we have the base a and we have the exponent m, and for the complete stuff we have exponent n. So now what we can do is whenever we have two exponents like this, we can multiply the two exponents, that is m times n. There is another way to write the same stuff, that is a to the mth power whole to the power of n. That is, what we can do is we can switch the exponents. When I do so, I'm getting a to the nth power whole to the mth power. So this one and this one are equal. So now here let me consider the stuff over here. Here we have base 2, the exponent 2, and for the complete stuff 2 to the second power, we have the exponent x. Okay, now what I am going to do is I am going to consider this particular rule over here. So that is, I am going to switch these two exponents. Then I am getting 2 to the x power whole to the power of 2, negative 3 times 2 to the x power. The evaluation of this 2 square is just 4, positive 32 equals to 0. Then 2 to the x power, the whole square, negative 3 times 4 is 12, 12 times 2 to the x power, positive 32 equals to 0. Okay, now I'm going to assign a new variable y for this 2 to the x power, because here I find 2 to the x power, here I find 2 to the x power. When I assign a new variable y for this 2 to the x power, I'll be getting a quadratic equation in terms of the new variable, so that I can easily solve for the new variable once I get the value of the new variable from which I can solve for x. So I'm going to assign a new variable y for this 2 to the x power to make the solving process easier. So since I have assigned y for 2 to the x power, so we can write y for this one. Since we have 2 over here, it will become y square, negative 12 times for this one, we can plug in y, then we have negative 12y, positive 32 equals to 0. Okay, now we have to solve this quadratic equation. I think this quadratic equation can be solved by factoring. So to solve a quadratic equation by factoring, we have to multiply the constant term by the coefficient of y square. In this case, the coefficient of y square is just 1. When I multiply this constant 32 by this 1, I am still getting a positive 32. Now what I have to do is I have to get two factors for this positive 32, so that the sum of the two factors must be equal to the coefficient of y, negative 12. I think negative 8 and negative 4 will work. When I multiply negative 8 and negative 4, I am getting positive 32. And when I add the two factors, negative 8 and negative 4, that is equal to negative 12, which is a coefficient of y. Okay, now in my next step, what I have to do is I have to divide both these factors by the coefficient of y square, that is 1. So when I divide negative 8 by 1, negative 4 by 1, still I am getting negative 8 and negative 4. Okay, now to get the two values of y for this quadratic equation, what I have to do is I have to change the sign of each of these two factors. Okay, now to get the first value of y, I have to change this negative sign, then I'm getting positive 8, that is the first value of y. And now to get the second value of y, I have to change the sign over here, then I'm getting positive 4. Actually, y is a variable taken by us to make the solving process easier. Now it has to be replaced by the original stuff, that is 2 to the x power. So now I'm going to plug in 2 to the x power for y in both the equations. Then I'm getting 2 to the x power equals to 8. Then here 2 to the x power equals to 4. Now we have to solve for x in these two equations. Actually, we have the variable x at the exponent. Whenever I'm trying to solve for a variable that is at the exponent, what I have to do is I have to get the same base on both sides. Once I get the same base on both sides, I can equate the exponents and I can solve for the variable x. For that, we have to write this 8 as a power of 2 and this 4 also as a power of 2. Already we know that 2 to the third power equals to 8. So 2 to the x power equals 2. We can write this 8 as 2 to the third power. and here 2 to the x power, 2 to the second power equals to 4. So this 4 can be written as 2 to the second power. Here I got the same base on both sides of this equation. So whenever two terms are equal with the same base, we can equate the exponents. Then I'm getting x equals to 3. And here also the same thing. The base on the left side is 2. The base on the right side is also 2. The same base. Then what we can do is we can equate the exponents. Then I'm getting x equals to 2. So solving the given equation for x, I got two values for x. One is x equals to 3 and the other one is x equals to 2.